through the Q&A box found below your screen. The moderators and panelists shall filter all the questions and choose questions that are directly related to the lecture to be read after both presentations. The selected questions shall be answered by the presenters after the lecture. Thus, it is highly encouraged that the Q&A box should not be overflowed with unnecessary questions or comments. Participants may use the chat room icon for comments intended for the moderators and panelists and co-participants, but not questions. Other relevant questions not addressed during the session may be emailed to asepcpdcommittee@gmail.com and shall be answered by the presenters via email. For participants who are not officially registered via Zoom, the webinar can be viewed through the official Facebook page of the Association of Structural Engineers of the Philippines at ASEP. Comments and captions on the Facebook page live broadcast will be turned off in order to engage participants and keep them focused. All registered participants are required to answer the webinar assessment questionnaires, or the WAQ, to be posted at the end of today's session. Participants are given 15 minutes to answer the WAQ. The feedback evaluation form shall be given before the webinar session ends. Failure to submit the feedback evaluation form shall be a ground for no certificate. The link to the Facebook evaluation form shall be uploaded in the chat room box after the Q&A forum of the before the session ends. Registered participants who do not pass the WAQ will only receive a certificate of participation. On the other hand, registered participants who reach 70% passing mark will receive 2 certificates: Certificate of Participation and Certificate of Completion. The link to the webinar assessment questionnaire shall be uploaded in the chat room box also before the end of the session. The applicable certificates and the link where you can download the presentation materials shall be sent to the registered email address used in this Zoom and Google form. Make sure that the Zoom and Google form email address should be the same. Make sure that the email address should be used in the same in both platforms. Okay, thank you. Thank you.
Thank you very much. Thank you very much, Sir Adam, for giving us the webinar rules for this session. So next, to give us the welcome and opening remarks, let's now call on our ASEP President, Engineer Rani Ison.
Yeah, hello. Thank you, Mac. Good afternoon, everyone. Or probably good morning to some of our participants, and good evening. We would like to welcome everyone to this free webinar regarding the Philippine earthquake model and the use of the ERI. We are very fortunate to have our distinguished speakers, Dr. Rhommel Grutas, a member of ASEP and also one of the specialists in PHIVOX, and also our past president, Villaraza, who is very knowledgeable in the earthquake recording instruments, so in the use of earthquake recording instruments. I would like to encourage everyone to listen very well. The Philippine earthquake model will be used subsequently. The results of the Philippine earthquake model will be used subsequently in the new NSCP 8th edition. We will now be moving from the UBC 997 to ASC 7-10 in terms of earthquake loading. And then subsequently also, when we listen to our distinguished past president, Villaraza, please listen very carefully on the proper use of the ERI. Now, we would like to actually, one of the reasons why we had this, why we're having this seminar is we would like to inform everyone of the proper use of the ERI. So we would like to emphasize that the ERI will not make your building safe. A poorly designed or a poorly constructed building, even with an ERI, will not be able to stand the effects of a large earthquake. So an ERI is a tool for us to be aware of the properties of the structure, but definitely all these records or all these data should be assessed properly by the structural engineer. So with that, I would like to again welcome everyone. I would like also to thank our sponsor, represented here by Mike Tungkol, which is Midas International. So we would like to thank them for sponsoring this webinar, and I'd like to welcome everybody again, and hopefully that you will be learning a lot from this webinar this afternoon. So with that, thank you very much, and let's proceed with our webinar. Thank you.
Thank you, Sir Rani, for the opening remarks. So moving now to our formal presentations. So to start with, our first presentation for this webinar session is on understanding the Philippine earthquake model. So let me introduce to you our first speaker. Our first speaker is a graduate of Doctor of Philosophy in Environmental Science and Technology and Urban Earthquake Engineering from Tokyo Institute of Technology, Japan, as a Japanese government scholar. He is also a graduate of Master in Civil and Environmental Engineering from Saitama University as an Asian Development Scholar and a graduate of Bachelor of Science in Civil Engineering. Our speaker attended several courses related to seismology and earthquake, such as the seismology course in Potsdam, Germany, geophysics course in Beijing, China, and a seismic design of structures course in Macedonia. He has also attended a course in probabilistic seismic hazard assessment in Geoscience Australia, Canberra, Australia. He is currently the head of strong motion and earthquake engineering section of PBOX. Let us please join me today in welcoming our first speaker to discuss to us the Philippine earthquake model, Dr. Rhommel Grutas. Dr. Rhommel?
Thank you, Engineer Mendoza, and thank you very much to the ASEP President, Ran Ison, Sir Adam, and Sir Kaloy, and also all the panelists of the ASEP. So I will share. Can you see now the presentation?
Yes.
Yes, we can see your presentation, Dr. Rhommel. Please proceed.
Okay, good. Okay, good afternoon to the participants. So with this presentation, you would be able to probably understand the basic of probabilistic seismic hazard assessment. And with this PSHA, we'll also discuss how the Philippine earthquake model was developed. So first, I will give an introduction on how the PSHA should be used. So the question is how to reduce earthquake fatalities. So in an event of a large magnitude earthquake, of course, numerous buildings will have damages, sometimes collapse depending on the construction. So with this, we have an issue on risk management. Okay. So this is the flow. When you want to study an area or already an existing structure and to identify the risk. First, who is worried about what and what is acceptable risk. So here we establish the context, and then we identify the risk, like what might happen to harm the things we're worried about. Okay, so we identify that risk. And we analyze the risk, like how bad might these events be and how often might they occur. No? For example, in Metro Manila, we already define based on the length of the fault that it would produce a large or a 7.2 magnitude earthquake. Now, the question is how often or when or how often might this earthquake of magnitude 7.2 will occur. No? So that is an issue of a probabilistic study. Then we evaluate the risk. Are they really something we need to worried about? Of course, if it's a large magnitude and we could see that we are very near the fault and the fault is there, no, the manifestation from the surface of, or there's a surface manifestation on the ground, then we need to be worried about. Then how do we treat our risk for such the source of a large magnitude earthquake? So we implement treatments, we improve our building codes or structural codes. So in this five, one, two, three, four, five, no, this is where the PSH fits in. This is the to analyze the risk. No, now why do we conduct probabilistic seismic hazard assessment? Now, the goal of seismic hazard analysis is not to understand how the planet works. It's a very big concept, but to provide a rational basis for decision, especially for engineers, no? By Frank Sharbaum. Now, why do we conduct PSHA? It's used for loading standards for building codes. That's why we uh, should incorporate in the national structural codes the design specification for critical infrastructure like power plants, dams, and other large structures or important structures. Now, to identify credible scenario events for disaster response planning and to use to determine insurance premiums by reinsurers. Lately, like the GSIS, no, and other private insurance companies approach PBOX if they could use the PSHA. Okay, and then inform risk-based decisions. Example, prioritizing risk mitigation measures among different hazards. Now, what is seismic hazard and what is seismic risk? So, seismic hazard is the probability of exceeding a given level of ground shaking at a particular location within a given time. And the seismic risk is the probability of exceeding a given level of social or economic losses at a particular location within a given time. So seismic risk would involve cost, kung gaano kalaki yung losses, no, in million or trillions of dollars. Now, seismic hazard cannot be reduced. No? You cannot predict earthquakes, okay? But seismic risk can be reduced, no, by strengthening or following the code when we construct a building or a large structures. Now, forecasting earthquake ground motion, these are the ingredients. For a single earthquake, we need to know the location, of course, and the size of the earthquake, the magnitude 7.2, magnitude 6.8, and then the ground motion level, and the question of the recurrence period. How often will it occur? No? So all of this uncertain, and need to be associated with a probability. So it is described by a probability density distribution function. No, so here's an example of probability distribution function, or a logic tree. No, so you impose, for example, a number of ground motion prediction equation for a certain crustal structure, crustal area. Then you do a logic tree. Now, there are types of uncertainty in doing probabilistic seismic hazard assessment. We have the so-called aleatory uncertainty. So it's an inherent randomness that arises from physical variability in a natural process. It cannot be reduced even with additional data. Example, the location, the size of the next earthquake on a fault, or exact details of the ground motion from the earthquake. So another one is the epistemic uncertainty. Epistemic uncertainty, ito yung due to incomplete knowledge about a phenomena which restrict our ability to model it. But it can be reduced with additional data, better constrained seismic data to determine recurrence model. Example, the type of magnitude distribution for a seismic source, no? The Gutenberg and Richter relation. So aleatory uncertainty, no, it can be measured. Like the probability density function, you can impose a probability density function and the logic tree. But the epistemic, yung incomplete knowledge, cannot be measured. So that's papasok dyan. It must be guessed. No? Yeah. Now, the PSHA, it's computed by the seismic hazard integral. So for each source zone, combined uncertainties in earthquake, so dyan mag-i-introduce, we need the size. So we have this equation for the magnitude, no? The rate of magnitude. So your data, seismicity data should be complete. You should have magnitude 3 in the database, magnitude 4, magnitude 5, and so on. And then the second is the location. No? So you should have an earthquake with different distances from the epicenter. And then the ground motion intensity in terms of distance. So how much the peak ground acceleration from the nearest 1 kilometer up to 10 and 100 kilometers. So these are the ingredients for computing your seismic hazard. So the PSHA methodology, these are the key ingredients, the source model. So with that, input seismotectonics, active fault maps, earthquake catalogs. Number 2, earthquake recurrence relationship, earthquake catalog, active fault slip rates. Number 3, attenuation relationship. Here we will introduce ground motion prediction equations or GMPs, site amplification maps, and you also need the seismic hazard calculation like the OpenQuake. Now, this is a whole picture or a recipe for computing the PSHA. So the top is what we call a map, the seismic hazard, probabilistic seismic hazard map. Okay, so with that, you need the ground motion here on the left and source zones here on the right. So ground motion, you need GMPs or ground motion prediction equation. Where can you get GMPs? From strong motion seismic data. Where can you get site amplification? By microsonation. So you need to have an idea of soil type, geomorphology, and topography. And you also need value of velocity measurement, usually shear wave velocity of the upper 30 meters or VS30. So for source zones, you need to have earthquake catalog. active faults, seismotectonics, and so on. Now, for slip rates, of course, you need GPS observation. So in PHIVOX, we have the team of Toto Bacolcol, wherein they deploy a lot of GPS observation, and there would be a GPS campaign. So they gather data and check the slip or the velocity movement or crustal movement on different areas. So here is an example. GPS, surficial velocity vectors from Bacolcol et al. 2012 or Okura 2015, wherein there's a study of Philippine fault zone or the PFC. So we have this 87 millimeter per year, or some examples, 85 millimeter per year, and so on. So that is how we have the data. That's how we gather data for slip rates. Now going back, site amplification, microsonation. Does PHIVOX have this map? Of course, we have site response atlas. This is for site amplification. We published Metro Cebu Site Response Atlas in 2018, Metro Davao Site Response Atlas, and what is inside the atlas is a VS30 map. VS30 is the shear wave velocity for top 30 meter of soil. So it's also in the table 208 of the NSCP for site classification. So this is needed. So we have also short period map, and this is up to 1 second. And we have the long period map from 1 second and above, up to 5 seconds usually. So when we introduce ASC 7-10 and 7-16, there is a value there of TL, that's long period. So with this map, you can also use some of this value, okay? That is for Site Response Atlas. So here in Metro Manila, we published a VS30 map for Metro Manila in exploration geophysics. So you can see the paper. So here we have the cross-section AA for shallow, VS profile in starting from the Manila Bay. So we have the coastal lowland. So Manila, we have this very near the coast, 168 VS30. And in the Central Plateau, here in Quezon City, you have the C10 and C11. It's Quezon City. So we have already rigid, no, because of the adobe, 535 meters per second. And in the Marikina, it dropped, no? So we could see the boundary between the West Valley Fault from the Quezon City and Marikina Valley. And then going up to the Antipolo, we have the base or B2. Okay. So again, going back. Now, how about GMPs? So we have, what is this strong motion seismic data? The next speaker will talk about accelerograph. So does PHIVOX have the strong motion seismic data? Of course. We have accelerograph data. We have, this network is different from the seismic network of PHIVOX. Seismic network of PHIVOX is a velocity instrument, no, deployed in different areas in the Philippines. But this one, this one is an accelerograph. No, it's it can record acceleration. So PHIVOX maintained 10 sites in Metro Manila since 1998. No, in 2011, the network expanded to Greater Metro Manila. So we put additional 30 for Bulacan and Calabar zone. So when I went back from Japan in 2013, I expanded this network. So 2013, we also deployed. In 2015, I deployed in Davao Region 12, strong motion in Davao Region. And in 2019, as of 2019, we have now a total of 94 strong motion stations in the Philippines. So this 2020, I think around is around 100. We deployed in Aurora. So if you could see the map, there's no station in Aurora. So we installed also in Baler, Aurora. Then for this year, and Bohol will also install. No? So that's the update. So what is the use of strong motion accelegraph records? Of course, as engineers, you need this. This is an open field ground motion, no peak ground acceleration in time history, an example of strong motion accelegraph for the event last April 22, 2019, a magnitude 6.1 earthquake. So if we check, the highest is in the Olongapo, OLC. No? It's 0.198 G or 198 gauss, no? Almost 2 G. And in Guagua, Pampanga, almost 2 G also, 0.188. And if you remember, Chuson Supermarket collapsed, no, very near this station in Pampanga. So you see, if we are designing, if we follow NSCP, our basis, our CA value is, or peak ground acceleration, our first basis is 0.4. Zone 4 should have a 0.4 G, no, design. Then you add distance from the earthquake and site amplification, then that 0.4 would increase. Or if you're in the adobe or bedrock, it will decrease some sort of. But this one, imagine 0.18, almost 0.2 G, Chuson Supermarket collapse. Now, another event, Cotabato earthquake, October 31. So we recorded near Digos, no, in Digos City, we recorded 0.3 G, no, with damaged structure. So if we compare in the intensity 0.3, so that would be intensity 7. So for 0.3, we expect damage, some sort for non-engineered structures. Okay, so how will engineer use this strong motion? Of course, spectral matching. You need this record or input time history to your design, no, and so on. So a strong motion network, the database, we already have the database. So acceleration, starting from 5 kilometers up to even 600 kilometers, we have the data of peak ground acceleration. But the amplitude, of course, this is updated from this. It's 100 gauss or 0.1. So we already recorded 0.3 G in the Cotabato earthquake. Now, ground prediction model, GMPE. So we have for active shallow crust, we studied the Xiao et al., Chu and Yang, Abraham, Burr et al., Campbell, Borzonovia, and Zool. For subduction interface, these are the GMPEs that we are studying. Intraslab, Yang et al., Atkinson and Bohr, and Xiao et al. Okay. Now we also did a statistical study using our accelegraph data, no, on which GMPE should we use applicable to Philippine setting. So this is the ranking of PGA up to 50 kilometer distance. Number 1, Fukushima and Tanaka. So Sadig, Chu and Yang, Burt and Atkinson, and so on. Okay, so how do we define seismic sources? This is to define areas within which the seismicity is the same such that it does not change in space and time. What are the inputs? Knowledge of seismotectonics, maps of active faults, earthquake catalogs, and seismicity maps. Seismic sources can be defined as background seismicity. So we do a polygon, fault lines, 2D planes, subduction interface, lines, 2D planes, subduction intraslab, 3D, and so on. So how can we show it in the picture? So this is the Philippine seismicity with different moment magnitude. And we clean that. We remove aftershocks. We remove 4 shocks so that we can use it in the PSHA. So this is now the PSHA database uh, from magnitude 5 to 8, 8.3. Now, defining seismic sources. This is the cross section. We have a Manila Trench. So the top, it's unclassified because we have background seismicity. This is, we introduce area sources, so unclassified. So crust and upper mantle in the Philippines is around 28 kilometers up to 30 kilometers. So we have now this, the crust, no, and lithosphere, the orange one. So here we introduce the intraslab, no, based on the focal mechanism. I will discuss this beach ball here, the focal mechanism. This is how you know the fault plane or fault rupture. So we have the intraslab, interface, and crustal, okay, and different rupture mechanism classification. So how do we define the fault? What kind of fault? The strike slip fault, normal fault, thrust fault, and so on. So we have this focal mechanism solution of PBOX, wherein we captured every time an earthquake, there's an earthquake, and we plot this beach ball. So an example of this is the Negros, no? In 2011, magnitude 6.7, but it did not manifest surface rupture. So how do we know? So with this, we know that it is a thrust fault based on the beach ball. This is how the movement from the source originate and exploded or propagate in the surface. So we can say blind because it did not manifest. Wala ka makikita sa surface. So this is how we defined the buried faults, no? And so on. Okay, defining seismic sources. Again, we have the active faults and trenches. You can visit Geohazard+ PH for an updated faults and trenches of the Philippines. We have the area sources and so on. Now, we define, again, updated the crustal sources. With this, we have the crustal earthquake on the left. These are the crustal sources, 1, 2, 3, 7, up to 7. And we have the interface earthquake, the orange, is starting from the Manila Trench, or red is the trench. Then going right wards, we have the orange seismicity, that is the interface earthquake. And moving down deep is the intraslab. These are the yellow one, the deeper earthquake, the intraslab earthquake. Okay, so this is how we define sources. So we have crustal earthquakes, interface earthquake, and intraslab earthquakes. The 3D model can be shown here at the right. So now this is now the updated PSHA model for the Philippines, wherein we have the source model, site model, and the ground motion prediction model. We have active shallow crust, subduction interface, and intraslab. So for active shallow crust, we have 4 GMPs: Chuen Yang, Burr Atkinson, Burr et al. Xiao, 2006. First, for logic 3, we tested weight of 25% each. So ganon. Then subduction interface, again, this 4, 25% each. And intraslab, again, and so on. So we use calculation software of Open Quake Engine. So we have a collaboration with Global Earthquake Model for this study. Now, the PGA maps for rock sites at 10% probability of exceedance and 2% probability of exceedance in 50 years, or the 10% probability in 50 years is the 475-year return period, and the 2% probability of exceedance in 50 years is the 2,475-year return period. Now, for PSHA 2009 collaboration, this is the result for 10% probability of exceedance in 50 years. And if we compare it to the previous result of the PEM published in 2017, so napakalaki yung difference, no? So na-improve siya much, no, for this 2019. So ASEP requested the SS for the incorporation in the code, no? So we produced this 2475 SS, or short period, or the 0.2 second, no, 2475 year return period. So this is the draft map, and this will be peer reviewed by also ASEP. If they accept this, then this will be incorporated in the code. So for source model, we use the PVOX GEM collaboration. For GMP model, we use the same as the updated, of course, PVOX Global Earthquake Model collaboration. And for site model, we use Class B. And this is for the S1, or the spectral acceleration at 1 second, 2475-year return period. So this is the PHA modeling result to be incorporated in the National Structural Code of the Philippines. So I think that's all for my presentation. And I hope na nakapag-contribute ako sa knowledge about the probabilistic seismic hazard assessment. So thank you very much. So you can visit the PVOX website, no? And here are the telephone numbers and fax numbers.
Thank you very much, Dr. Rhommel, for that very informative and interesting topic that you presented to us. Before we move on to our question and answer, which is actually later part of our presentation, let's now first move on to our next part of the program. And that part would be a presentation of our sponsor for this webinar session, which is the Midas IT Philippines. And we would like to call on the account manager of Midas IT Philippines. We have engineer John Michael Tool. Did I correct? Michael John Tool, I'm sorry. So Engineer Tool, you can have the virtual floor.
Hello, good afternoon, everyone. Is my audio clear, sir? Hello, sir. Hello.
Yes, Michael.
Yes,
Okay.
yes, it
Yes, Michael. So
good
it's loud and clear.
Okay, I'll proceed now. Good afternoon, everyone. I am Michael John Tungkol. I'll be discussing about the two main activities of Midas IT Philippines here in the Philippines for this month and in the upcoming months. I'll be discussing the Midas Academy Expert Program and then the Productivity Support Fund Program. So to introduce myself, I work with Midas IT Philippines as a regional account manager. This is not. And then in your screen right now is my contact information. My email address is philippines@midasit.com. So first, let's move on to the outline of my presentation. I'll be discussing about and then also introducing the Midas IT as a company. And then I'll also be briefly discuss about the family program and then what is the whole academic expert forum about, also, as well as the Midas Productivity Support Fund, and then how we can continuously provide the support to our users and also to the engineers interested to use the program. First, for the Midas program introduction, since we have very limited time, all throughout this presentation, I'll be showing in your screen a QR code. You can take a picture or scan it right now and then just bookmark it so you can review it later. The QR code contains the Midas key folder in which you can see all the important details in my presentation as well as the supporting documents and presentation. So for the technical presentation for Midas Gen, which is our program for um, vertical structures, and then Midas Civil, which is our program for horizontal structures, you can see the technical presentation presented by our technical support engineer through the QR code. So you can just take a photo or scan it right now and then just bookmark the link. So moving forward, I'd like to discuss the history of Midas as a company. Our founding year was actually in 1989 when our CEO, now CEO, first developed Midas Gen. And then after years of development, 2000, we were able to commercially distribute the program in Korea first. And then after 4 years, we were able to establish our global business offices in major cities all throughout the world. We are very proud after several years, we have founded the Midas IT Philippines here in Makati, and then from 2015 we have been trying to provide a very good technical support and also the program to all the Filipino engineers extensively from Luzon to Mindanao. So here in Midas, the only way we know to do the business is to listen to our users, to the Filipino engineers. So first, they wanted us to do the hands-on training session. When we first provided the program here in 2015, we had to acknowledge that there's very few or very relatively small of community of users here in the Philippines. So when we did the management here in the Philippines, we did a aggressive hands-on training session from Manila, Cebu, and then Davao. We have been also partnering with organizations like ASEP to provide and to reach more engineers here in the Philippines. We have a very reliable and knowledgeable technical support team. Right now, we already have 4 technical support engineers here in the Philippines catering only the needs and the assistance for Filipino engineers. We have maximized our online presence through online trainings, webinar, especially now that we have been trying to do the seminars remotely through webinar kasi we are taking advantage or trying to find alternative ways to provide support to our users and engineers in this uh, pandemic. And also, we have been trying to provide flexible payment terms. Our users can attest that we have been, even especially now, we are trying to be more flexible about our payment terms, considering that most of the companies here, almost all the companies have been affected by the change of lifestyle that we are currently experiencing here in the Philippines. We actually believe that our strength is our user. In your screen right now are just few of the companies who have been using the program, both Midas Gen and then Midas Civil. So you can just review this, and then maybe you know some of this company. You can ask their engineer how was the technical support, how was the program, and I think I'm very proud to say that there's been a really good improvement in our technical support. And then with the development of the program, which happens every 3 to 4 months, we have been providing updates of the program. So yeah, we believe that the strength is our users. Um, Moving forward with the training sessions that we are doing, since 2017, we have been trying to provide, as I've mentioned, the training sessions all throughout the Philippines. We started the Design the Future with Midas in Davao. We've done this in Cebu, Pampanga, in Palawan as well. And then we have been doing the annual Bridge to Bridges workshop since 2019, 2018 rather. The first annual Bridge to Bridges was in Cebu, in Manila, and then the second one in 2019 was actually in Cebu. And right now we are now planning how to do it through the online platforms that we have. We are doing the regular monthly training sessions here in our office, which we provide for free. We try to visit other parts of the Philippines to actually provide the sessions for free. We've done it in Davao, Cebu, and Palawan. in Bicol as well. I'm sorry. And then the annual user conference, which we do, which is a platform for our users to share their knowledge, because we believe here in Midas that the only way that we can thrive in as a community of structural engineers is if we share our knowledge, help each other, and then through this, we are giving our users the platform to share to their fellow engineers, structural engineers, what they have learned, and then what how Midas helped them out with these with the challenges that they faced in doing the structural designs of their projects. Moving forward with the next part of my presentation, I'll be discussing about the Midas Gen Academy for Forum for Vertical Structures. So it's been how long? 5 months, 4 months since we experienced a sudden change in our lifestyle. So we acknowledge here in Midas that the only way to to move forward is to try to adapt with the changes in our lifestyle. So right now we are launching this Midas Academy, Expert Academy Forum to produce Midas Gen Expert for RC applications. Soon we'll be doing this for steel, for special structures, but now we'll be doing this first for RC structures. So this will be our schedule. There will be a 3 week program or course, a series of training. For the week one, there will be every week there will be a Midas Gen user application presentation, and then after that, we'll be doing the hands-on training based on the user's application. So first we'll be discussing the theory, and then next would be the application. If you can see from the schedule, there will be a rerun. So every time if an engineer is not available for the first day of the training, then they can attend the second day of, or they if they have clarification from the first day, they can just attend the second day, just so we can make sure that the quality of the training that we have been providing will not be jeopardized just because we're doing everything now via webinar. So for the week one, Engineer Junjun Santos and Engineer Mark Carino will be doing the presentation. And on the second week, it will be with Engineer Adam and Adam Abinales, and then also with our technical support engineer, or Engineer Mark Espino. The topic for the week one will be for basic RC modeling, design, and consideration. And then the second one will be a hands-on demonstration for basic modeling, design, and consideration. For this presentation, we'll make sure to provide all the necessary materials to all the engineers. So even if after the webinar, they can still review the topic, and then they can recreate the said presentation. We'll also be providing certificates, and then as well as the certificate of Midas Expert for RC application. So now let's move on to the to the last part of my presentation. What is Midas PSF program? PSF stands for Midas Productivity Fund Program. This is an initiative by Midas IT to continuously promote the productivity and promote the better output in this trying time. So ever since we started doing the business here in the Philippines, Midas has been trying um to help out not just the Filipino engineers, but actually everyone who has been affected by any trying time that tests our limit. From the Taal volcano eruption to this very challenge that we are facing, Midas has always been there, not just to assist, but also to make sure that no one is being left behind while we all move forward. We would like to think here in Midas that um, we cannot just stop doing doing the things that we would like to do just because everything changed in our lifestyle. We have to move forward, find ways to adapt, and this is one of our ways to help out engineers, Filipino engineers, in getting in moving forward. So the benefits of Midas PSF program would be, first, there will be an extraordinary discount offer. Um, we'll be providing as much as 40% discount for all the engineers who will be applying for this PSF program. So from instead of paying 100% of the standard pricing, we'll be providing from the time period of August, we'll be providing uh, the the program for up to as much as 40% discount. And then we'll also be doing free customized learning, a private scheduled training lessons um, for our users, and also group learning session with our experienced technical Filipino engineers. And then you can the engineers or the company can also choose to pay the said program within 6 months. So you're not just getting the discount, you're also getting a flexible payment terms, which you can also pay via credit card. So, sir, how can I join how will I know if I'm eligible to join this program? So these are the qualifications. You should either be a SME, small medium enterprise for an engineering consultancy, or you're a freelancer. Then you can apply for the PSF program. An engineering firm in the Philippines since 2015 can also apply for the PSF program, and a sole firm or a freelancer or any structural engineers who are interested to be a freelance structural engineer can also apply for the MIDA Support Fund program. And also SMEs from under three engineers can still apply for the said program. So here is the application process. First, you have to fill up the application form. When you scan the QR code, or when you visit the link from the QR code, there will be folders which can help you how to apply. And then you just have to secure the form. And then after that, we'll be sending you a non-disclosure agreement form. Since the offer will be with a huge amount of discount, we'll have to make sure that the offer will remain confidential and no other party will have access to the offer. And then after you send us back with a signed non-disclosure agreement form, we'll be sending you you will be evaluated from your activities with BIDAS, with the webinars that you have attended, seminars that you have attended, and then after that, the offer will be provided to you, and then you can evaluate it yourself if you will be able to get the program. So moving forward with how Midas can continuously provide support to you, we have, as I've mentioned, we have a very good technical support, and then our online platform has always been good. Even before this pandemic happened, we have been doing the online support through online for engineers, even outside Metro Manila, through GTC, the Global Technical Center, and other platforms. Even Facebook is now a very good tool for our users to reach out our technical engineers. And then lastly, I would like to invite you all to the Midas Academy Expert Program. This will be a free program. I hope everyone will be interested to join and take advantage of this free training seminar. We'll also be providing a 30-day evaluation for the said seminar. That would be all. If you have any question, you can email me at philippines@midasit.com. Once again, I'd like to thank ASEP for inviting and giving us the opportunity to share this information with our participants today. Thank you, sir.
Thank you, Engineer Michael Jantongkol, and apologies for mispronouncing your name earlier on. Yeah. So yes, Midas has always been supportive of all these ASEP activities that we are having, and I think the software is really very promising. So for you who haven't checked the capabilities of Midas, we are asking you to try these offers of Midas IT, and with the very strong after-sales support that they have here in the Philippines. So I think you can get all the benefits of a good software, particularly for structural and earthquake engineering analysis. Thank you again, Michael, and thank you, Midas IT Philippines. So if you have questions, please type in your questions in our Q&A boxes. We will all answer these questions during our question and answer portion. At this juncture, we will now move on to our second presentation for this webinar. So moving forward, I would like to introduce our second speaker. Our second speaker is a recognized authority in earthquake engineering and has over 40 years of extensive experience in earthquake and structural engineering design and evaluation of structures covering low, medium, and high-rise buildings, ports and harbors, industrial facilities, bridges, heavy machinery foundations, pressurized pipeline structures, power plants, military installations covering both static and dynamic analysis. Our speaker has over 42 years of experience in performing site-specific seismic hazard studies, vulnerability and risk studies for lifeline, environmental, and essential facilities. He has a postgraduate diploma from the International Institute for Seismology and Engineering in Japan, including an advanced earthquake engineering course, which he obtained in 1987. He took units for MS Civil Engineering in University of the Philippines, Diliman, and graduated Bachelor of Science in Civil Engineering from the University of Santo Tomas. Our speaker is a fellow of the Association of Structural Engineers of the Philippines and served as its president from 2014 to 2015. So with that, I would like to say welcome to our next speaker, Engineer Carlos Villaraza. Welcome, Sir Kaloy, and I am now giving the virtual floor to you. Sir Kaloy, I think you're on mute.
Sorry, because I belong to the past century. Anyway, when I look up, it's not that I'm looking up at the sky and thinking of nothing. No, I'm looking at the screen because the other screen is on top. Now I would like to start with my video. Can I just check if it is working?
Please do so, sir.
Is it okay? White. Let me arrange it. Okay, is it okay?
You can see your screen, sir. Just the presentation view. Maybe you can now click the present. This one's now okay. It's now okay, sir.
Can you see this presentation?
Yes, sir. Yes,
okay,
sir.
Good. Yes. Okay. For a while. Okay. Now I will be talking about the earthquake data interpretations, or what we call, or it is related to what we call the earthquake recording instruments. But before I start, it would be good to interface with our first presenter, Dr. Rhommel Grutas, what he has presented, that of the work of PIVOX, and then that also of Midas. But for the third one, for Midas, it can cover any kind of software that you might be using that touches on the dynamic analysis, on earthquake analysis. Okay. Now let us go first to the introduction to earthquake data interpretation. Our outline would be on the we will talk about seismology and earthquake engineering. The first one will touch on the basic seismology. The second one would be on earthquake engineering, covering topics: physical effects of earthquakes, what are building codes, then seismic code provisions, development in the National Structural Code of the Philippines. The fourth one is seismic instrumentation in buildings per NSCP 2010. Now, between the 2010 and 2015, there is not much difference at all. And the third one would be just introduction to earthquake recording instrument data processing. I would say that you are very interested in this one, but to go into this one, it will take at least a week for us to get really a big hold on it. But you can ask questions later on, and then I will try to answer them before going into another lecture series on this earthquake recording data processing. On basic seismology, this is just a review. This is our Earth. It's so beautiful. When we look at it from the outer space, it seems to be just one solid sphere, but it is not. The Earth is divided into, if we cut a cross section, it is divided into the crust, upper mantle, lower mantle, outer core, and inner core. Now we are much interested in the crust. That is why during the presentation of Dr. Grutas, he said about something about the BS30, the 30 meter depth, that we are very much interested in analyzing the behavior of our structures during earthquakes. But earthquakes actually occur, the epicenter usually would be at the upper mantle, or what we call from 30 up to the 70-kilometer zone, which is what we call the Benioff zone. And most of our earthquakes, the dangerous ones, would occur in the level of the upper mantle of around 50 kilometers, 50 kilometers, 20 kilometers, 15 kilometers. That would be causing such a great effect on our structures. But when it is deeper, 70 kilometers, the effect would not be that much. So we just go into the review. Fault line, we know. And then what we have seen also that there is what we call the blind fault, wherein there is no manifestation at the surface. And then we have the epicenter, which is the vertical projection of the hypocenter. And then we have the seismic waves traveling radially. And then we have the focus fault line underground. Okay. Now, there are two types of earthquake vibrations, the surface waves and body waves. The surface waves are those that are traveling at the surface or at the crust. And then the body waves would be the one traveling inside. And then after this, we have what we call an introduction on our instrument. Graphically, the instrument is very simple. The accelerometer or seismograph, or what we call the velocity meter or the displacement meter. It's just a pendulum type, no? And then earthquakes generate seismic waves, which can be detected with a sensitive instrument called a seismograph. Okay, this is just a graphical representation. So when the ground moves, then horizontally, then it is recorded before in the 70s or 80s or the 90s. It is just recorded on a piece of paper. But now they are what we call in the analog. Now it's already the digitized or digital record. But before, in the 80s to the 90s, we were so happy to have the analog data. And then this is the drum. I think people still have this one, but they can be placed now in the archive, no? Okay, as a museum. Okay, what are these? Movement of ground during an earthquake is converted into electrical signal. It's very important to note, no, electrical signal tracing out the wiggles of the earth's shaking. That is why in our analysis, we make use of what we call the electrical engineering equations, like what we call the spectrum, velocity spectrum, acceleration spectrum, and so forth. And then we go into what we call the other analysis, like the later on I will discuss it more now, just to avoid confusion. Okay, there are two kinds of waves that travel from the source. We have the primary waves and then the secondary waves. The primary waves move in a compressional motion, just like this one, no? At this figure. Okay, compressional motion. So the P wave will always reach the instrument faster than the secondary wave, because the secondary wave moves in a shear motion perpendicular to the direction the wave is traveling. A seismogram is a record of the ground shaking recorded by a seismograph. Like this one that is shown in this figure, we have a record of the 1989 Loma Prieta earthquake taken in Norway. So this is an old one. We have new ones like here in the Philippines. We have now the that one from Negros, and then we have that one of Bohol, and that one of Mindoro. So we have all of these, you know. But basically, we have to look at the P wave and then the S wave. The P wave and the S wave arrival are very important because they are the ones used to locate the epicenter of the earthquake. So here it says earthquakes are located by measuring time arrival between P and S waves in a seismogram. And then there is an equation or a graph that will show you how far it is. For example, in this figure, there is a recording station located at 3,400 kilometers away from the epicenter or hypocenter. Other ones 2,800, 4,800. you measure this one, the time arrival, the time difference, and then you will be able to get the distance from the source to the recording station. So from these ones, we came out with a theory of plate tectonics in the 1800s, in the late 1800s, 1890s, I think. No? So with all of this data, we were able to plot that there are several plates that how binds the Earth together. And then for the plate tectonics, there are three types. We have the divergent, convergent, and then the transformational. For the divergent, we can see this in Africa, and then in Iceland. Africa, it is in Trinidad, Lake Victoria. And then in Iceland, we have California, we have the Manila Trench, and the Philippine Trench. It is convergent. No? For the transformational, the Philippine fault is a transformational fault, but combined also with convergent and divergent, convergent and transformational. Now, for the ones that, from this plate tectonics, we were able to divide the Earth into several tectonic plates. We have the Pacific plate, Australian plate, African plate, South American, the Philippine plate, okay, and so forth. Now, these are the records of the Philippine earthquakes until the 1990s. This is an old picture or data. I got it not from PBOX, but still from Pag-asa when the seismological part was still under Pag-asa. But the most important here is that you can see where the concentration of earthquakes are. Actually, it is in Mindanao. Most of the earthquakes occur in Mindanao. And then there are three types of plates within the Philippines. We have the strike slip. This is the one. And then we have the thrust, the normal faulting, and then the thrust faulting. If you are a seismologist, there is a big difference between the acceleration at the normal faulting and then the thrust faulting. For example, for the normal faulting, the higher acceleration would be at this point. And then for the thrust faulting, it will be at the right side, at this part. Okay? But for us, structural engineers, we just divide it into, just give it a one acceleration value. For example, we have, for example, the peak ground acceleration, design acceleration of 0.4 G for zone 1, for zone 4. And then we have 0.3 for zone 3, and then 0.2 for the rest of the Philippines. But we're not using anymore the zone 3. That was deleted way back in 1992. We just divided then the Philippines into two zones, the zone 4 and then those that belong to the zone 2 or lower. These are the fault lines in the Philippines. Okay. Not all are active, although they are shown here. But if we take, for example, the return period, starting it at a 475 year return period or 2,475s, not all, even though you are near a certain fault line, it doesn't mean that you belong to a zone. There is a classification in the NSCP, type A, B, or C fault. Because the activity, you have to consider the activity of these fault lines, you know? Okay? But PBOLs have helped us define which are the active faults in the Philippines that has to be classified under type A fault. Now we go to the another effect of the earthquake. It would be the tsunami. Now PBOLs have, this is also important for us, especially in designing our buildings. Before we were silent about this one, but if you look at the NSCP 2015, some horizontal loads are already applied due to this kind of effects, the tsunami. Now, Philippines has provided us with a map of the tsunami map or the tsunami prone areas in the Philippines. Okay, so the blue one, historical tsunami. Okay, and then the red one, it is the potential. Okay. Now we go now to the basic earthquake engineering. This is the ground rupture in Bohol. The photo, I took it from that of Pibos, no? Ground rupture in Barangay Anoanang, Inabanga, Bohol. Okay, you can see here the displacement of around, this is around 5 or 6 meters. And then there is a house that is quite near the fault line or the point of rupture. And then we can see here that it is still intact. Why? Because the earthquake force is a function of the load within a structure. And this house did not have any heavy loads on the second floor. So that's why the effect of the earthquake was not at all significant, or we can say it was negligible. And then this one was taken in Cebu around 40 kilometers away. So 40 kilometers away, we can see the ceiling falling, okay? Now, for structural engineering, I think we have to take over from this responsibility from the architects because we have already experienced ceilings falling not only in Cebu, but also in the Clark Airport during the last earthquake, I think a year or two ago, wherein the ceiling of the airport collapsed after that earthquake in Zambales, the epicenter as dictated by Pibos as located in Zambales, so San Marcelino. And then this can also be the effect if the design is not well. For example, for this intersection, for this joint, you can see the orange part, which is the downspout. It is embedded into the column. So during dynamic loads or earthquake loads, then the cover can break down as seen in this one. And then this is a house on top of the fault line. You can see it fell. Why? Because there was insufficient reinforcement at the walls or nothing at all. The reinforcement was only 9 or 8 millimeter diameter and spaced at more than 1 meter, around 1.2 meters. Another effect is the liquefaction. This liquefaction, especially we have witnessed this during the 1990 North Luzon earthquake. It was very evident from Baguio down to Manila. There were so many what we call the sand boils occurring, okay? But particularly in Dagupan. What happens during liquefaction? Development of high water pressure or water pressure due to ground shaking. And then it can result into surface settlement or bearing failure of the foundation. Dr. Grutas mentioned about the failure of buildings in Pampanga, in Porac. I forgot the name of that building. And then he said, but it's only 0.18 G. How come it fell? Actually, it fell not because of the ground shaking itself, but because of liquefaction. It was due to liquefaction. If we try to analyze the videos, it was due to liquefaction, not due to the acceleration effect on the building itself. What are building codes? Building codes are sets of regulations governing structures, covering the design and construction, alteration and maintenance. This is covered in our NSCP 2015. Then the second one is the minimum requirements, safeguard health and safety, welfare of building occupants. So it is very, very important to remember these two items, sets of regulations, very structures, then the minimum requirements. Why? Because why is it that we need to instrument our buildings now? Because our buildings now are medyo, they are not anymore the simple buildings that we used to know. Ngayon kasi parang ang buildings are like work of arts, ano? Talagang umiikot-ikot kumisan, very irregular and so forth, ano. Kaya with the ano, it may not be the behavior may not be covered completely by the code, but with our instrumentation, it can capture the behavior of the building during earthquakes. Kaya very important yan, ano. And then it need not reach the, for example, the let's say the magnitude 8, 7 earthquakes. No, even for a magnitude 5 or 4, we can already know how the behavior, how the building will behave when it is subjected to the magnitude 8 earthquake. Kaya dun nga kanina may sinabi rin si Dr. Grutas also said something about the 475-year return period and then the 2,475-year return period wherein they are developing the SS and the S1. Objectives of the NSCP seismic requirements: resist minor earthquakes without damage. Number 2, resist moderate earthquakes with limited structural and non-structural damage. Resist major earthquakes with significant damage to structural and non-structural elements, but with limited risk to life safety. And then the fourth one is to resist the most severe earthquake ground motion ever likely to affect a site without collapse. Dito naman papasok din is the importance again of the instrumentation. Why? Because to resist the most severe earthquake ground motion, it can even go beyond the yung itong tinatawag natin na magnitude 8 eh. We can have a magnitude 8.5. Pero now, is our structure safe? With proper instrumentation, we can project up to magnitude 10 kung how our structure will behave. Pero dito pa based design. Kaya importante, that is why, sorry, I forgot that there are going to be some people who do not understand Tagalog, ano? Okay. For performance-based design, we have to do what people is doing, ano? Doing a site-specific study, considering the aleatory and then the epistemic uncertainties. With this one, we will be able to project, for example, high-rise building, when it's 30, 40, 50 stories or 100 stories, then we have to do a site-specific study, and then this can be only done if we know the behavior. Kapag nalaman natin, if we come to know about that one, then we can model it properly. Now, the evolution of seismic base year of our code. Way back in the 1920s, actually in the 1940s, 1900s, we already have a seismic design criteria, no? Every building should be designed with a 0.1 G times W. Ito yung 0.1 peak ground acceleration. This was taken way back to the 15th century, no? Study ito ni Galileo, itong 0.1 from the pendulum. Pero this was applied in the Philippines in 1875. So lahat ng structures natin from 1875 up to the 1920s, it was 0.1 W. Okay. In 1966, we changed it because we are not anymore under Spain, and then so we adopted that of the United States. It became a ZKCW. Z is what we call the zoning and also the soil effect. Nilagyan na dyan, zone, may zone factor na yan. Considering also the soil properties. We have type 1, type 2, type 3 soils. People whose age is around 60 up will know this equation, pero the younger ones will not. Ang younger ones would be the 1976 code, wherein we introduced the factor of the soil interaction. Yun. Now comes 1994, we came up with the ductility factor in RW. The RW considers the ductility factor, and then the zone, the zoning, and then the C would take in the soil effect. Now for the 2010, this is now the equation. We have the period, and then the ductility factor, and then we introduce the velocity velocity. Pero ito, may if you look at the response spectrum, the CV starts at around 1 second, and then the CA ends at around 1 second. Kaya this captures both the acceleration and then the velocity. Because for very flexible buildings, we have to use the velocity, not the acceleration. Especially for our bridges, we should stop using the acceleration. We have to start using the velocity response spectrum. I is the importance factor. Okay. So, punta na tayo dito, Ito, makikita nyo I'm just showing you this one. Kasi, when we talk of instrumenting buildings, we go generally into the PBD, performance-based design. Do I still have time? I think so.
Yes, sir. Just go on, sir.
Okay, sige. So 50% probability of exceedance 58, that is 72-year return period, and then 20% probability in 50 years, that is 225, 10% probability in 50 years, that is 475, 2% probability in 50 years, that is 2,475. So ito yung ginagamit natin for performance-based design. Also for nuclear design. For nuclear design, we start with the 50-50, and then the 475, 2,475, and then the 5,000-year nuclear plants. Yung 5,000 lagpas na dito we did not tackle it anymore dito. Okay. So, this is a record from the Christchurch Hospital, Christchurch earthquake in 2011. This was from a instrument located at the Christchurch Hospital, 8 kilometers from the September 4 and February 22 events. Now let us compare with the National Structural Code of the Philippines 2010. Makikita natin na the code of this is also the difficulty if we just use the PSHA. The Code of New Zealand is based on the PSHA studies. But they forgot that kaya nga kanina sabi nga sa atin ni Dr. Grutas, yes, for the aleatory, you cannot change it kahit na marami kang data. But they forgot about the epistemic. The epistemic shows them that it should be of higher value. Now, kaya sa Philippines, we never change it, kaya many consider our code as conservative. Yes, in a way, it is not conservative at all, but decided to use a higher value because of the uncertainties. Actually, I was part of the code, Seismic Code of the Philippines since 1987, kaya medyo matanda na ako, matanda na. Okay? So ito, So for the NSCP, we can see here that it captures that of the New Zealand earthquake nung sa Christchurch. This is a fault line which did not have any record at all. Okay, so but if our code was used, then it should have resisted well the earthquake of New Zealand in 2011. And then the blue one is using because the red one, the NSCP 2010, was based on our study way back in 1987. So this one, I based it in 1987, I think. I think in 1996. I make this study. So, but it still will capture that of the Christchurch earthquake. Okay. Now we go now into the seismic instrumentation of buildings per NSCP 2010. Okay. In 1992, we already said that every building over 14 stories in height should be instrumented, but this was never applied. Okay. And then again in 2001, over 6 stories in height with an aggregate area of 5,500 square meters or more, it should be instrumented. And especially the buildings over 10 stories in height, regardless of floor area. Pero in 2010, we decided, and it was approved by DPWH, that every building in seismic zone 4 over 50 meters in height should be instrumented. Should it be instrumented? Yes, it should be. Ano? Kaya kasi the objective of seismic instrumentation is the safety of the inhabitants and then the building operations. Because a building, for example, like now, we are experiencing it dito sa COVID. For COVID, we have not been working for mga 4 months na or going 5 months. Why? We cannot operate talagang fully gawa kasi of the virus. Pero if we have a major earthquake to hit Metro Manila, it will be around 6 months before we can start operating. And not all buildings will be operable. Some buildings might have serious damages. And then who would evaluate it? Well, kasi for a structural engineer, he can only evaluate a building. The fastest would be around 1 week, modeling and so forth, checking. The fastest would be 1 week. And then we have around 2,000 buildings sa Metro Manila. So you can see, matagal yan bago binal. Kaya it is very important, safety of the inhabitants and then the building operations. Furthermore, we have so many condominiums. So what will we do with the almost 2 million people who are housed in those condominiums? It means that they have to wait for 2 months, 3 months, 4 months before they can go back. It is a big disaster for the country. Kaya the buildings need to be instrumented, And then for the emergency response of the government agencies, assume to us, maganda na yung ginawa ng TVOLs, they have already what we call here the risk map. So the government can already prepare, for example, where to mobilize their yung emergency response teams. But short pa rin ito, we have limited rent funds, It pinpoint which areas have suffered the most. Kasi from the records of the buildings, with the records of the building, we should be able to analyze a building, the safety of a building within a day. Kung mabibigay sa ating records, records, and then we will just use our programs like the MIDAS, ETABS, and others, yung mga softwares natin. So madali yan, I am not promoting MIDAS, Kasi MIDAS, ang ganda ng MIDAS kasi, because it is interoperable. You can input into it the data that we will get from the yung instruments natin. And then lastly, the improvement of building codes. Ito makakatulong sa codes natin to reduce loss of lives and properties during damaging earthquakes. Okay? Now, the accelegraph, ito ang content ng it's accelegraph. There are 3 accelerometers. Ito yung accelerometers, So, kapag as a whole, ang tawag dyan accelegraph. Pero yung mga components niya are called accelerometers or velocity meters or displacement meters. Depende kung ano use mo. And then it measures full motion in 3 dimensions. This is the X, this is the Y, and then this is the Z, the vertical. So from here, we can get the peak ground acceleration, PGA, and then the velocity or the ground displacement. And then common to the 3 would be the intensity. Ito, na sinabi natin sa ating, we said in our specs of the instruments, they should be able to give the output kasama dun ang intensity, So with the intensity, even though the building engineer might not be an engineer or a structural engineer, with the intensity, he can picture, ganito ito. So, pasado pa ito ba? Kasi our building should be able to resist intensity 7 or 8, and then it should not collapse at intensity 10. Kaya makakaya natin yan. Alam ito ng kahit sino, madali. This is more of a layman's data, Pero the peak ground acceleration, magdi-differ. Mamaya, i-discuss ko ito sa inyo ng konti, magdi-discuss. The peak ground acceleration that we read is not the one that are used for design, or is not the one that is being resisted by the system. Iba, mas mataas. We have to convert that into energy. Energy, kaya meron tayong power spectrum, and then go back again to yung, I forgot the term, mamaya na lang, Okay. Now, network sensor sample. Katulad nito, this is a accelerometer. Microtremor to strong motion accelerometer. Ito, You can buy that as a set. Ito yung nabibili ninyo, Whatever kind of instrument you are using, then you can see that it's placed inside the building. Then records data and trigger file in CF card. So we have the card here, or the USB, in simple terms, Sends seismic information data such as seismic intensity, predominant period, and waveform. So ito importante, Okay. In our code, we said there that it should have been a process data. It should be able to give immediately the response spectrum, acceleration response spectrum. Pero in my experience, when I was testing many instruments, the majority do not give this data as required by our code. Hindi, Kaya medyo the data, correct it, do a correction, and then before inputting it into our software, yung whatever, so Midas, ETABS, and so forth, SAP, and so forth. Okay, this is the graphical location of instruments. We have, for example, here, first we have at the roof level, then mid-level, and then the ground level. Generally kasi, this is also something, we can use the ground level. Pwede mo ilagay yan sa, sa second basement or third basement. The behavior would be the same as if you relocate it at the kunyari may 5 basements yan, at the 5th basement, you don't need to locate it there. Kasi gagastos ka lang maglalagay ka pa ng cable, mas magastos. So, second basement would be good enough. Okay. But we forgot, pero we should have always one at the free field. Yung nasa labas, Itong sa free field kasi, it will always give you a lower acceleration. And then, ito yung ginagamit natin sa actual, this is the reference, natin, na design. Reference design natin. It's always the free field. Not the one at the second basement. Second basement will almost give you the same, except may dumping kasi yung building, Kakaroon ng dumping, Okay. So this is the one, typical instrumentation schemes proposed by USGS. Okay, yan. Tayo tatlo lang, ito lang, A lang tayo. Pero sa B, nilagyan nila sa mga gilid wide because this is an eccentric building para makita nila yung torsional effect. So with this one. And then for base isolation buildings, iba din, Base isolation buildings will give us a very, very low acceleration. Mababa, It can cut the acceleration to siguro mga 80% to 90%. Kaya kapag nag-base isolate ka, makakatipid ka sa design ng building, For example, for 10-story building, roughly you will save mga 50 million pesos. Mahina na, 50 million. Okay. So ito, another schematic design, deployment of sensors and recorders sa mga buildings. And then, lagger, makikita natin na sumasayaw waves. Kaya kailangan meron itong correction factor. The correction factor. One of the things that you can use, marami itong available sa market. Meron tayong seismo signal, meron yung yung sinabi kanina ni Dr. Grutas, yung free something, yung free use of the software. Doon, may correction factor din yun. So, mako-correct, this has to be straightened. Kung hindi, lalagpas yung when you plot this into the response spectrum, pwedeng tumaas ng gusto, response spectrum mo. So, it seems that your design has been exceeded, pero hindi. It has to be corrected properly. Okay? Okay. Now, the budget. Well, mura lang kasi, siyempre, dito direct cost lang ito, ha? Cost breakdown. Cost of 12 channel, approximately $50,000. There's a 4 channel. Ibig sabihin to, per channel kasi, 3 yan, So, ibig sabihin, 4 locations yan. 4 locations. Why? Because normally, we have a triaxial at the free field station. Nasa vicinity ng building. Kung pwede, Pero hindi ito ginagawa generally, Because we rely on the data of PBOX. Okay? Kaya, nagiging ito, 9 channels lang. 9 channels lang, Okay, selection and installation of instruments. First, develop an instrumentation scheme including the sensor locations. That is the work of the earthquake engineer. The one that is specified sa ating code, or sinabi doon structural engineer, but with experience. Pero you don't just locate the instrument anywhere, Meron tayong tinatawag na tolerable eccentricity, but not, for example, there was a building that I saw wherein it is a rectangular building, and then the instruments were located. Yung isa nasa kabilang dulo ng building, and then isa nasa gitna, and then the other one is at the other end, Hindi pwedeng ganoon. Mahirap yan, It will not give you the real behavior of the building. Okay, when subjected to earthquake. And then the earthquake engineer, the supplier, and then the owner's representative should review the site to determine the exact sensor locations. Kailangan yan. And then the recorded location is selected on the basis of security, that is the logger. The instrumentation undergoes preliminary calibration in the laboratory. It is the first, Pag dineliver na yan, i-check uli yan ng engineer, ng instrument engineer. Hindi yan basta inilagay lang, okay na, no. It has to be checked. It has to be checked whether it is working or not. We have a method of checking this one, using ito pag-aaralan natin sa another seminar, kasi kulang oras natin talaga dito, We can use dito a very simple one, Excel. In Excel, you can use this one. You can check the instrument, using the Excel software. Okay, this is an example of a recorded instrument of accelerations at the Pacific Park Plaza in the US. But this was, I think, in the 1980s, So makikita natin, this is at the free field, it's only 0.26 G. But when you look at the ground level, it became 0.21 G because of the damping of the building. And of course, the roof is more flexible, nasa taas na yan. So it gave you a 0.38 G. Peak acceleration yun. Peak acceleration. Okay? And then when we plot this one, makikita natin the NSCP covers all yung response, while the 1979 UBC, because this happened in 1980s, So it was designed, ang liit ng design acceleration ng UBC 1979. And yet when I was studying, mali ang pagkakagawa nito nitong author nito, USGS. They made a mistake because the seismologist was the one who did this one. But for design purposes, magkaiba tayo, This should have been higher, nandito yan. It should have been nandito. Yung acceleration niya, sa SD type soil. So that is why we as structural engineers should know how to use the data, earthquake record data. Kaya ASEP made this presentation sa inyo, a general view, so that we can see the importance of us structural engineers knowing also a bit of seismology and a bit of earthquake engineering. Okay? So this is how we process na, no, yung mga data. Retrieval. So, pagkatapos ng earthquake, so we had to retrieve, ano? Okay. Usually, ganito makikita natin ano, sa data. Kung hindi process, ano, makakalito, sabihin natin, nasa dyan X, Y, Z. The data from accelerographs, ano, kasi this is in CWB form, which is, ano, yung file, ano. So, text editor. Kaya, in notepad form ito. Pero pwede natin itong ayusin using the Excel. Kapag na-process natin conversion, ano, ganito mangyayari na yan. Ayan, ano. Kaya madali. XYZ na. XYZ na yan, ano. So, ito yung time. Ito yung time. Z, north, south, east, west. So, mapoprocess na natin yan. And then, we have the raw data. After that, it is not just, makikita natin dito yung velocity tumataas, ano. So, we have to apply a correction factor to bring this to zero. To zero dito, no? Kapag nasa zero natin yan, then correspondingly, our response spectrum will go down. Liliit, ano? And then this acceleration response time history, okay naman siya. And then this also the displacement, okay siya, except for the velocity. Okay. This is the smoothed time history from PVOX. Ito, ano? This is the raw data. Kinuha namin, ano? Okay. Data retrieval and processing. Data from digital recorders are filtered. It has to be filtered. Just, kinatanggal namin dyan yung nasa taas, yung 0.05G. 0.05G sa baba. Why? Because every building may dumping. May dumping yan. Kaya lumiliit ang what we call the acceleration, ano? Yung acceleration bumababa yan. Kaya with the application of the dumping, 5% dumping, 2% dumping, then liliit, ano, liliit yun. Kaya ginagawa natin, just remove it using a filter of 0.05G. Secondly, response spectra calculated for periods, linear plots of relative acceleration, velocity, response spectra, and pseudo-acceleration, velocity. Response are prepared if specified. Ito, in-specify natin ito, ano? But unfortunately, hindi lahat ng suppliers are giving us this one. Kaya a-analyzing pa yan ng structural engineer, ano? Kaya nung earthquake, kumuha sila ng external consultants from another country just to process all the data that was during the Mindoro earthquake. But it should not be. Kailangan meron na tayong ganyan. Ilalagay mo na lang sa softwares mo, no? So our engineers can immediately respond to the requirements of or the questions of the owners, ano, building owners or this yung mga manufacturing plants natin, ano. Can they start operating or no? Kung hindi, matagal masyado, no? It will take maybe 1 month, 2 months, 3 months, 6 months, ano. Pero for a manufacturing company not to produce for a month, this is a big loss, eh. Kaya kailangan natin maayos ito, no? Maayos natin ito. Ito yung Fourier analysis. Kaya electrical engineering talaga ito, eh. We have to understand also Fourier analysis. Yung gustong pumirma sa dito sa instrumentation, it is just a matter of signing, ano? But you have to understand Fourier analysis and then power spectrum. Ayan yan, no? So that you can get the amplitude and then the predominant period. Ano ba yung a good advice to the owner or to the structural design consultant ng owner. Okay, now we go into the processing. Sa processing, we just, ito kanina yung procedure of viewing the time series. Susunod, because the time series is so mahabang masyado yan, no? Kaya tinatrancate natin yan, eh. Kaya meron tayong filtering system, yung 0.05G, tatanggalin natin, ano? And then, those that are outside of that, hindi na covered, ayun na lang ipoprocess natin. Kung hindi, napakatagal, ano? Because we can shorten the time from one day analysis, pwede lang yan 30 minutes to 1 hour, no? Kaya ganyan ang ano. So we have to truncate. And then after truncating, we perform the fast Fourier analysis and then frequency breakdown. We have to get the predominant frequency of the system. Is it very near our assumption or nagkakaroon tayo ng what we call the resonance with the ground, ano? And then power spectrum scaling. Dito kasi itong dalawang ito, fast Fourier and power spectrum scaling, diyan nagpalitan ng palitan yan. Ano yan eh, we move from fast Fourier to power spectrum to fast Fourier, and then after that, we will be able to arrive at the time series. And then that is the one that we will input into our softwares. So inputting it into a software is very fast and easy. Pero analyzing it between the fast Fourier and power spectrum and then into the time series, that is where the bulk of the work and the criticality of the analysis rest. Itong dalawang ito. Okay? So that's it. Kaya before an earthquake, what we do, we have to be prepared. Katulad ng ginagawa ng mga taong ito, they are preparing even before an earthquake. Lalagay ng brace, anchor latch, and then ties. Ano? So we have also to prepare. Kaya with the proper instrumentation of buildings, we can prepare way ahead. Ano? Even with a magnitude 4 earthquake or intensity 4, kaya na natin, we can project that to intensity 7 or magnitude 7 or magnitude 8 earthquake. We have tried it, our company has done it. And then nakita namin na pwede pala, no? So we avoid so many unknowns, na we are just, yung sabihin natin, this is what the code says. But we know that the code is the minimum. Kaya nga, in the code, it says there, we are amenable to a performance-based design analysis. So this is it. Thank you very much. I will, kung may mga questions kayo, this is a general presentation na mamaya na lang, ha? Okay, thank you.
Thank you very much for that very informative lecture, Sir Caloy, as always. So now we move forward to our question and answer portion of this webinar series. So I will be reading some of the questions that were typed in by our Zoom participants. So let me see the questions. So some of the questions were already answered by Dr. Rhommel Grutas, but we would like to answer these questions live for the benefit of other participants as well as the listeners via Facebook Live. So one of the question, maybe Engineer Grutas, Dr. Grutas, can you turn on your video? Yes, okay. So this is a question addressed to Engineer Grutas. In ASEP 2015, it is mentioned that the maximum moment magnitude for seismic source type A is magnitude 8.4. What is the basis of this magnitude 8.4 in the ASEP?
Okay, so if you check the historical catalog or seismicity of PHIVOX from 1645 up to present, the largest magnitude earthquake happened dito sa Pilipinas ay 8.3, I think, 8.3. So I think that's the basis for the 8.4 cutoff.
Okay.
8.3, 8.4, yes.
Okay,
magnitude.
So there's a basis, so it is based on earthquake records. Is that correct, Dr. Grutas? Okay.
Yes, based on the historical earthquakes.
Okay, thank you very much. That's very informative. Another question, maybe this question is for Sir Caloy, Villaraza. When applying an ERI on a building, is it really required to locate it in the center of mass of the structure? Now, if the location of the center of mass is not accessible, do we have any tolerances as to how far we can relocate the ERI from the center of mass? Sir Caloy?
O sige, based on experience lang ha. Kasi it should be computed. Pero based on my experience, you can go offset ng up to 3 meters. The effect will not be much. 3 meters, ano? But don't go into 5 meters, ano? Because there should be a correction factor. Based on my experience lang ha, I don't know. So of course, ayun yun. It should not be located talaga sa center of mass. Ayun, no? You can go a little bit, 1 meter, 2 meters, no? It will not matter. It will give you the same. And then the best is you can do some experiments. Kasi ngayon, because whoever asked that question, because an accelerometer is so cheap. It is only 400 pesos. So you can buy, siguro you can buy 10. And then you ilagay mo sa pole, and then usually our computers have already the softwares to get the acceleration, Then i-align mo yung mga sensors mo, move it, and then you can see what the effect, from 1 to 3 meters, 1 to 5 meters, 1 to offset of 10 meters. Then you can see the effect. So that is a very simple analysis, Simple analysis lang yan, ha? Pero we will take this, Engineer Mendoza, after na lang siguro when we go deeper into really in the instrumentation, then we can tackle this. How do you do this kind of experiments, Yes.
Okay.
I hope I answered the question niya, ha? So it should not be, hindi naman kailangan talaga sa center of mass or center of the It can, pwede kang lumayo. Huwag lang extreme, ha? Huwag lang extreme.
Yes, thank you for that, Sir Kaloy. Maybe a follow-up question on this earthquake record instrument. The question is, can you really use the raw data from the earthquake record instrument directly as an input to a structural engineering software for structural analysis? Can you really use the raw data from ERI as an input to a structural engineering software for analysis? And can it really tell you if the building is safe or not?
That was the intent of the code. Kaya in our NSCP, that was specified, Pero in my actual practice, sa ganyan, when I was checking, hindi, They're giving us a very raw data. So we have to apply the correction factor. Kaya kanina pinakita ko, hindi ba? Nakataas yung record. So you have to zero that through filtering. And then, but the filtering softwares are available naman, Available naman sa market. It's not so expensive. Or some are free. Katulad yung free access, yung sinabi ni Dr. Grutas, So you can use that one.
Yes. I think yung baseline correction, yan, important yan. Yung tilting ng records, very important kasi if your records are tilted, of course you get very high PGA, very high PGA. So there are processing softwares for strong motion to process the raw data.
Yeah. So after that, you can use that ipapasok mo yan sa software mo, Pero don't forget yung truncating. Very important thing, truncating, ha?
Yes, of course.
I think not you, Dr. Grutas, but the one who asked the question. Kasi if you input yung raw data, it can take you 1 day to finish an analysis of a building. Pero it should be able to analyze the critical part. Mga 30 minutes lang yan to 1 hour. For a 40-story building, ha? We're talking about a 40-story building.
Okay, thank you for that, Sir Kaloy. Maybe this question is addressed to Dr. Grutas. The question is, for the new Philippine earthquake model, what is the latest seismic event that was considered for the magnitude recurrence relationship? Dr. Grutas?
Yes, the 2018 earthquake date or seismic catalog. So we have the PHOX catalog, and then we merge it to the GEM, Global Earthquake Model catalog, and then fine-tuned from the ISC, International Seismological Commission. Although PHIVOX, we always send data to ISC. That is to complete the global catalog. So that, I think, answer the question.
Okay.
2018.
Okay, so kind of check that paper by Dr. Grutas. I think there's a publication already released regarding this matter. Now, this question is addressed to Sir Kaloy Villaraza. The question is, Sir Kaloy, you mentioned about the liquefaction risks. The liquefaction is dependent on PGA, and overestimating it will significantly affect the assumptions of liquefaction potential. Can you discuss the variations of PGA in the surface and bedrock level?
Okay. Kanina kasi we said there is a travel of the primary wave and secondary wave. Now when it reaches the ground, that's why it becomes a surface wave. Pero ito there is the migration from the bedrock to the surface, there is a reduction, it can also be an amplification. Kasi if the soil is soft, there is an amplification. And then PHIVOX has done this study, kaya meron sila up to 5 seconds. Dr. Grutas, I think it's 5 seconds,
Yes.
1 second up to 5 seconds. Importante yan, Depende yan sa, ayun ang tinatawag natin na you have to compute the predominant period of the ground. Kasi dun papasok yung effect, magkakaroon ng migration from rock to soft soil and then to the surface.
Okay, I hope that answered the question. Another question here is, in the Philippines, how much is the price range of ERI? And maybe we can provide a cost that we can somehow present to our clients so that we can encourage them to install ERI in their building.
Ay? Sa palagay ko, it will be unethical for me, Kasi sa akin lang, I'm more of the technical, I think you negotiate it na lang with ang pinakamaganda kasi, get 3 bidders and then negotiate it, among the 3 bidders. Whoever gives you the lowest, ayun na ibigay mo. But there has to be tama yung yung output. Kasi nagkaka-problem tayo sa output, yung data. They should have given us the corrected, may correction na, corrected data. Hindi yung raw data. The raw data, mahirap mag-analyze na yan. Matagal, It will take time. Even for me, mabilis na nga, but I still have, for example, migrating from Fourier transform, power spectrum, Fourier transform, power spectrum, and then I go to the yung output, sine-check mo lahat yan, matagal. That will add me siguro 3 hours. 3 hours, instead of a 30-minute analysis, it becomes 3.5 or 4 hours, So ganun katagal pero kaya kailangan yung the engineer who would sign, make sure you check the instrument, the output, sorry baka kumalimutan, the instrument has to be anchored, hindi yan nakadikit lang ng ng glue. Kasi kapag nag-earthquake, pag tumalsik yan, magbibigay ng mataas na record or mababang record. Kailangan naka-anchor yan sa simento. Sa simento yan sa floor niya, kailangan may base siya. There has to be a foundation, concrete foundation.
Yes, yeah. Usually naka-bolt yan naka-bolt.
Naka-bolt. I saw kasi some naka-glue, naka-epoxy, I-bolt mo yan.
Okay. This is one good question for Dr. Grutas. The question is the PGA, the short period and the 1 second response that was issued in the seismic map of the DPWH BSDS is a product of the Philippine earthquake model? What's the correlation between the DPWH BSDS seismic map and the product and the Philippine earthquake model. Dr. Grutas or Sir Carlos Villaraza, maybe you can also comment on this.
You can go first.
Sige.
Yeah,
Okay. Sa ano kasi no, we have to look again when DPWH made this map no. It was made kasi before Peoples issued the PEM 2017 for Metro Manila. Kaya magkaiba no. Nagmamigrate tayo kasi katulad we have discussion with Dr. Grutas na with yung ASEP and Peoples na ang ginagawa natin ngayon, we have to adjust to the American code ASCE. Pero Peoples use the Japanese code, kaya magkaiba talaga. Magkaiba yan, Pero pagkatapos, after everything has been computed, magpaparehas ang result. Except, iba lang ang mga parameters, Kaya, ayun ang kailangan importante. We have to know the assumption. Para walang mali, parehas tama yan eh. Pero it is only when you cannot use itong equation ito, ipasok mo itong data ito, Hindi. You have to be consistent. Yung equation mo, and then yung data mo. Ayun lang, it's a matter of putting the right data into the equation. Ayun lang, ayun lang yung nagtanong, he has to be careful, He has to look at the equation. And then what is the design equation is he using? Is it the Japanese or is it the American or is it the British? Magkakaiba yan.
Yes.
Is it the German DIN? DIN magkakaiba, no?
So maybe Sir Carlos, as a follow-up question here, ang sabi dito, so what map are we going to use? We have the DPWH seismic map and then the PEM map.
I prefer the PEM. No, nakita ko si PEM namin before hindi kami nag-agree and ASEP did not agree much also. Nagkakaroon kami ng difference with people. But after meeting then clarifying, ganun pala nakita ko the people's map is talagang very applicable sa atin eh. I prefer the P-box. I personally I prefer
Yeah, just to clarify, yung PEM 2007 as I presented, malaki na, nag-evolve na yon. Our GMPE for crustal in the PEM 2017 is only 2 GMPE. So we just put weight of 0.5 or 50% for crustal, 2 GMPE. But now, for the SUM project, the one that will be submitted to ASEP, we will use 4 GMPEs for crustal, and then we have 3 crustal, intraplate, and intraslab. So in PEM 2017, there's no intraslab. Okay. So I think
so maybe
the PSHA is evolving. The one in DPWH done in before the PEM 2017. So the PM 2017 has already evolved now in 2020. I think yearly it's evolving. Data comes in from the slip rates, GPS, and fault mappers, and so on.
Okay. So maybe another question, maybe this is addressed to Dr. Grutas. Is there a future direction to consider a better site model where we will consider a more accurate VS30 data instead of just assuming that all VS30 in the Philippines are bedrock or 760 meters per second? I think Sir Kalay can also answer this.
Okay, yeah. For PSHA, you need to calculate first from the bedrock, and then if you have a site model, then you do a site transfer function, and then you add the site response. But previously in 2017, the NHA requested PHIBOX to put already the VS30. So we put very rough assumptions wherein we do not have VS30 But in PHIVOX, we have, as I presented, we have site response atlas like Metro Cebu, site response atlas, Metro Davao, site response atlas. We will produce Metro Manila, site response atlas, together with Metro Iloilo, Metro Pangasinan area, liquefiable area, Tarlac. We will produce VS30. And to produce the VS30, we use a lot of instrument. We have refraction microtremor. We have PS lagger. PS lagger, you need a borehole and you put the sensor and you shot vertically. You have the P wave. Then you have the wood and you hammer it. You produce S wave. Then you will have the VS30 from the borehole. So we have also PS lagger. We have single station H/B technique. We have Geocarte, the one that is used in Japan to produce the SDS and SWS. We have GPR. We have many more equipment to produce the VS30.
Thank you for that. Those are very informative, Dr. Grutas. Another question is there a possibility that an acceleration recorded in an ERI instrument is much higher than which is given in our code, 0.4G? Is there a possibility that an acceleration recorded in an ERI be greater than 0.4G? Maybe Sir Kaloy?
That is a very theoretical question. pero just to okay, when we look at the records, the best kasi, that's why I want sana if we can migrate sa future generation, maybe 20 years or 50 years from now, we go into the energy na. Because our design of our buildings is as a system kasi tayo eh. Pero we are actually migrating towards that one, na kaya nga sa atin, it is just a rule of thumb na sinasabi natin, there should be a parang backup system, when one fails, the other one will migrate yan eh. Hindi babagsak yung structure mo, Kaya kasi, sorry, nawala ako sa question. Ano yung question? Sorry, can you please repeat, Engineer Mendoza? What's the question? What is the question?
So what's the possibility that the acceleration recorded be greater than point?
Kasi we have to see, an instrument is an instrument. You have to average. For example, kaya kailangan, it requires experience, Kung minsan katulad ng, it is like looking at when you're checking the heart, itong, not angiogram, but yung sa heart, if it is not an expert, pwedeng ma-misinterpret yan ng doctor na, another doctor na, it is a skip beat. Pero no, it has to be properly interpreted eh. Kasi kahit ang spectrum natin, kung minsan biglang may tumataas. Kapag tumataas, kung minsan kasi nadi-displace yung instrument eh, o yung component and lagger mismo. Kaya sabi ko nga, it has to be bolted. Sabi din ni Dr. Grutas, it has to be bolted. Hindi lang with yung epoxy, kasi pwede matanggal yan eh. So with this one, ganun din, kaya kung minsan biglang tumataas. So a building kasi, we have what we call yung kapag na-overstress ito, kahit isang pulse lang, na-absorb yan ng building eh. Hindi nagko-collapse ang building, hindi nagka-crack, Kaya na-redistribute, kaya tinatanggal natin, tinatangkit yun. Kaya that is why, in initial pa lang, in filtering, tinatanggal na namin yung 0.05. Tapos, kaya mas maganda sa analysis natin, it is not just looking at the time series, you have to go back into what we call the power spectrum and then migrate again to past Fourier and then power spectrum Fourier and then go into the modeling. Kaya ng time series, para ma-filter out, marami kasi diyan mga noise eh, pati mga unknowns. Kaya yes, sige. Ayun that's the question, why isang hindi mo sinasama kunyari naging 3G yan or 4G or 5G, kapag pulse lang yan, hindi inaano yan.
I think
okay, I might also add. Yes, if you are very near the fault, for example, West Valley Fault, and the earthquake is magnitude 7.2, very near the fault, you would experience around 0.5, 0.6, up to 0.7 G. So if you have an instrument at the base of your building, you would experience that. But it depends on the frequency because you are very near, so very short. Yung earthquake time history very short lang, but yung pulse ng peak ground acceleration is very large. So sa modeling, we computed we can experience around 0.7, okay, 0.6 to 0.7, very near the fault. No? So once the building goes higher at may instrument ka doon, mag-i-increase yung acceleration. It will increase even up to more than 4G. 0.4G. 0.4G.
Okay. I think a follow-up question was raised. Can we really actually use an ERI instrument to determine the structural health of a building directly?
Yes. Properly interpreted, yes, you can. We have been using this especially the analysis of yung historical buildings, and then lately sorry, I cannot tell what building we checked a building dynamic analysis using the instrument dynamic instruments pero modified na, pero it's similar to an ERI pero ang ERI kasi ang masyadong broad ang range niya pero ito high frequency because what we did was to analyze the joints to locate where the failures are. Kasi namang presence of micro cracks. Nakita namin, nakuha namin location of micro cracks. And then it jived with the analysis, theoretical analysis using a certain software. Lumabas. Parehas kami.
Okay, sir. Additional question to that, sir. Can you use the displacement that was recorded in an ERI instrument or in an ERI to compare it with the displacement obtained in a structural engineering software such as MIDAS or ETABS? Can you directly compare the displacement obtained in an ERI to the displacement obtained from ETABS, for example, or MIDAS, Jen?
Actually, that is the one being used for what we call the PBD, performance-based analysis. We use that one, the instrumental record, and then that of the theoretical, and then the instrumental record. So we have to play around that thing, Yes,
Okay.
we use it.
I think this question is for Dr. Grutas. In the ASE 7-16 and 10, they are referring to MCE as MCER, or the risk-targeted maximum considered earthquake. And in our PEM model, I think the maps are based on maximum credible earthquake, which are considering uniform hazard. So do we expect that we will also follow the move of ASCE 7 to use MCER in the future?
Yes, I think yes. We have a collaboration with ASEP. So I think Sir Kaloy can answer. Yeah, we will.
Yes, Engineer Mendoza, it is 7-16, wherein the MCER. 7-10 or 7-05, it's only MCE. Now, is there a difference, big difference? Now, FIVOLS is doing it for us. So it's a big help, Pero in my experience kasi, hindi masyadong effect, No? Except that for a certain square kilometers, we have a risk factor because we are following the Americans. Pero we have to use another kind for the Philippines kasi the boundary conditions of the Americans and then the Philippines or other Asian countries are quite different from the Americans. America is driven sa economy tayo, but the Asians are life safety. So that's why there is a difference. For example, there is an acceptable, for example, for them a square kilometer 3%, 5% is acceptable, but for us no. Sabihin natin, it should only be 1%, 2%. Kaya magkaiba, Magkaiba. But this will be decided by the committee, with the Committee on Earthquakes. We are working with FIVOLS, and then with the practitioners, and then the other, what we call yung mga maapektuhan, So probably we have to include one time DPWH and National Housing.
Sir Kaloy, there was a follow-up question in your response kanina about using the displacement obtained from ERI, no, and comparing it with the displacement using a software like MIDAS. Can you really compare the two, even without performing performance-based approach or something? Can you elaborate on your response daw? Sabi dito sa mga nagtatanong sa atin.
Hindi, yung displacement kasi, the displacement, for example, let's talk of displacement, ano? Ang PBD kasi is always based on displacement eh. Thus, binabalik natin yan, ano? Pabalik, ano? To get the, is the structure safe or not. Kasi, we have to consider the rotation ng joints and so forth. So makikita natin nga, that's why I said, sa future, ano, we have to go into energy method eh. Sa ngayon, yeah, okay lang yung acceleration, but acceleration and velocity, it is ano eh, a crude method yan eh, very crude. Kaya nga maraming factor of safety eh. Kaya kung minsan, tama, hindi ko na sinasabi, tama rin ang people said, theoretically, ito yun, ano? Pero bakit tayo, bigla sabihin natin, hindi ganyan yan. Kasi we want to simplify it with our practitioners, ano? Simplify, kaya ang daming factor of safeties. Ang daming factor of safeties, ano? Kaya, ano, yung, kumisan hindi magkaintindihan eh, yung whoever, ano? Kaya kailangan talaga, yung when you work together as a team, ano talaga yan, you have to be open, ito yung mga assumptions namin, ano? Ito yung mga kulang. Pero kung kunyari ngayon, ano, if he's using the PBD, it can be compared directly, compared directly. But for example, you will transform that into energy, into acceleration. No, depende, ano, if your building is a high-rise building, acceleration may not work. Baka velocity pa, no? Third integration na kasi ang acceleration from displacement. Eh.
Okay. Thank you, Sir Kaloy, for that clarification. This question, I think, is addressed to Dr. Grutas. Is there a tendency that after a seismic happens in a specific area, it will change the peak ground acceleration in that area? Maybe Dr. Grutas, you already responded to this question behind the scene.
Yes. Every earthquake will be different from the other earthquake. Number one, different magnitude. For example, first earthquake, magnitude 7. Then followed by another earthquake, magnitude 6.8. Of course, there will be difference in peak ground acceleration. And also the distance from the source. I mean, the question is peak ground acceleration will change from the characteristics of the ground. I think it's not yet elaborated, but the answer is different earthquake would have different acceleration depending on the magnitude, your distance to the fault, and your site. No, so it will change the acceleration depending on that 3 parameters.
Okay. This question can be addressed to both speakers. The question is, how would you recommend carrying out the site-specific PSHA? Or probably, I will rephrase this question. When would you recommend carrying out a site-specific PSHA? Are there any criteria to be used to recommend such study?
Yeah, I think if the structure is very large, for example, dam and historical buildings, you know, and very special buildings and so on. So, or very costly building, then you need site-specific. Means you need geotechnical investigation, you need to drill borehole, you do the shear wave velocity testing, and with that you have the PSHA for the rock site or adobe, and then you add your details of your geotechnical investigation or VS study.
Sir Kaloy, do you want to add on that one?
Yeah, I agree with what Dr. Rhommel said, that for special buildings, there has to be a site specific. For example, what will come out with what we are now working, no, ASEP and FIBOLS together, it cannot be used siguro for ordinary buildings up to 10 stories, 10, 15 stories. You can use that for PBD, yung the 475 and then the 2,475 year. But if it is a very irregular structure, kahit na ilang stories lang yan, no? Irregular, very, very long, yung very wide na structure, mag-iibang behavior, Kasi you have to use time arrival, yung space, tawag namin ito, spatial and temporal analysis, magkaiba na yung behavior, It is not a matter of acceleration, designing it for this acceleration. In 19, mga siguro 1969, wait, sorry, 69, I experienced this one, ang haba-habang warehouse kasi, nagka-earthquake. We designed properly the columns, pero yung mga roofing, umangat, nagtupi-tupi, gawa kasi of the displacement, nagsalubong, haba kasi ng span, ang haba ng span. It is 100 meters by 80 meters. So, iba ang behavior, Kaya yung mga ganon, kailangan mo ng site specific. Kukunin mo na doon yung time element, and also the space, space element. So, magkakaiba yan, Pero kung ordinary buildings, okay lang. You can use, Kaya special structures, sabi ni Dr. Grutas, there has to be a site specific. You cannot just use the yung map natin na gagawain for the performance based design.
Okay. Another question. Is there a limit or threshold in acceleration or velocity or displacement of the structure which can be used to compare to the maximum response from the seismic instrument or ERI? So I think if I will rephrase this question, what would be the standard limit or threshold that we will use in comparing the maximum response from the ERI instrument for our building?
The question is directed
to you, Sir Kaloy. Yes, sorry.
Practical purpose. Okay.
Mhm.
The instrument is just a record nga yan, Kaya nga kanina sabi ko, it has to be interpreted by an experienced engineer or earthquake engineer, So many things have to be considered. Katulad nga kanina sabi ko, migration between power spectrum and then Fourier, Kailangan gawain yan, Kasi pwedeng yung signature hindi mo makuha, kapag hindi experience, It cannot just be directly from the book, Yan, tsak, ayan na yung sagot, No. Kaya nga, you take responsibility for that one. Ayun ang natin. Pero generally, yung what is recorded sa instrument would be adaptable na yan sa code natin, Because we are doing a study talaga ng extreme earthquake, na extreme event na yan, Na yung 2,475, that is an extreme event. Unless you are doing ngayon yung nuclear plant, It is another story.
Okay, thank you for that. We still have a couple of questions here. I'm just checking our ASEP secretariat if we still have time. Another question, I think, is addressed to ASEP itself. Is seismograph mandatory to all buildings that are more than 60 meters high? OBO, I think Office of the Building Official in Cebu, requires the installation of ERI for buildings more than 60 meters already. So is there a specific requirement in the code that specifies that limit?
ASEP, yes, there is. Nasa code natin yan. Yeah. 50 meters, higher than 50 meters, nasa code yan. It has to be instrumented na.
Okay. Let me check other questions. Okay, are we expecting that the upcoming NSCP would introduce this MCE from the Philippine earthquake model? Are we expecting the update of the seismic map in our NSCP based on this Philippine earthquake model?
I think Sir Adam, Sir Kaloy.
Okay.
Maybe I
Yeah.
can answer that. Well, in behalf of the project, Sam, yes, yes, it is. We are migrating from UBC 1997 to ASCE 7-10. And for the meantime, using the Philippine earthquake model, we'll be adopting the ASCE 7-10 for the meantime in the next edition of the NSCP.
This question, is there a validity of calibration for ERI or earthquake recording instruments? Are there some like a calibration validity?
Adam, ako na sasagot? Will I be the one to answer? Okay, I will
Yeah.
answer.
Yes, Kaloy,
Okay.
yes.
Yes, there is a in the code kasi it is written there. There should be a periodic inspection if the instrument is working, and then for example if it is not working, then it has to be repaired. Then I think it's only a certain number of days that the building can be without an instrument. After that, the instrument has to be installed again. Nandun na kailangan yan, so maybe 1 month or 2, I don't know. I cannot recall now the exact number of days, Pero the reason here is that there are many buildings that are already instrumented. So we will be able to capture, kunyari walang instrument itong building na ito, it is under repair, by statistics, the data can be taken from other buildings. But the only problem here is, kawawa yung owner. Because for example, that is a very important facility. And then the 3 recording instruments are out. And then the losses of for let's say a power plant na lang, maganda ang power plant, mas kabisado ko A power plant, ang penalty kasi ng power plant is around 1 million pesos per day. Kapag if it is a 400 megawatt power plant. So that is the loss per penalty ng government to the yung operator. 1 million pesos, or 1 million pesos, $1 million, I don't know. Basta ayun, So, masyadong malaki. So, I'd rather place many instruments there. Kasi malaking masyado yung risk ko, Kaya importante. Pero kunyari, the 3 instruments, let's talk about building. 20-story building, there are 3 instruments. Hindi naman 3 sabay-sabay na masisira yan, Generally, may masisira dyan isa. I-repair mo muna isa, but you still have 2. Kaya pwede. It will not be a big loss to the operator of the building if there is an earthquake during the time na nire-repair yung isang earthquake, Except that hindi siya he cannot get immediately the result that he wants or pinpoint where the damage is sa kanya structure. Kasi that's why 3 yan, Ibig sabihin, kapag nakita mo may abnormality ang nasa middle compared dito sa first, then ang damage may be nando sa between the first and then the middle part. Kapag nasa middle naman and then the roof, nandun yung abnormality makita mo sa signature, then doon mo na lang hahanapin kung nasaan yung sira na damage na structural element. So that is the use of the of the instruments. It is very beneficial to the owner na we have not explained to them properly.
Thank you, Sir Kaloy, for that extended explanation. I think, yes, Sir Rani?
If you look at the NSCP, the requirement is every year you should have it calibrated or you should have it checked. And then if there is one equipment that is not working, the supplier should have a replacement. Yung tama yung Kaloy is correct. It should be working all the time, di ba, Kaloy? Yung equipment.
Yeah.
Okay. So Rani, since you already answered that question, maybe there's a question here that you can answer for the benefit of the audience and participants. The question is is it true that the NSCP will be abolished and will be combined with other building code? And what is the stand of ASEP about this? Is ASEP involved in this proposed change in the building code, Sir Rani?
Definitely, ASEP will, definitely the National Structural Code will not be abolished. No? There is an ongoing review of the National Building Code. It's now in Congress and Senate, and it's called the Philippine Building Act. What does this do? Of course, there will be the structural code will still be the referral code, but somehow they are streamlining all the different codes, and they are revising the National Building Code. So definitely the structural code will still be there, but the National Building Code will subsequently be revised. And then, of course, the other referral codes will also need to follow the Philippine Building Act. So we are involved in that. So Adam and I are representing ASEP in this Philippine Building Act.
Thank you for that clarification, Sir Rani. So a couple more questions about ERI. This question is, let me read it. The question is, can ERI capture vertical effects of earthquake? Sir Kaloy, can ERI capture vertical effects of earthquake?
Yes, because there are three components nga, no, para an accelerogram that is required by us NSCP. The vertical, the north-south, and the east-west component.
Yeah.
So there are three. Makakapture yan. Makakapture yan.
We are also entertaining questions from our, for our major sponsor, Midas IT. For those of you who would like to raise some question to our Midas IT, account manager, engineer Tungkol is also available here to answer some of your questions. So to continue, I think this is a PBD question. I don't know if it is totally relevant. In evaluating structures using ASE 41, clients have the option to choose its basic performance objective. And for basic performance objective, a different probability of exceedance is recommended, such as 5% in 50 and 20% in 50 years. Is there a way we can convert this spectral acceleration that is mapped on a specific performance objective to a different objective? I think Sir Kaloy, he is asking if you can change, for example, the map or the values given in a different, what do you call this? 5%, for example, in the PEM map, we have 2% in 50, and he wants to convert it to 5% in 50 years. Are there any references where we can convert values of SSS1 that are given in different return periods? I think that's the question. So can we convert the given return period in the PEM to a different return period? Maybe both speakers can answer this question.
Yeah.
Okay.
Because PBD, tama yan, the owner can dictate. That is in PBD. Pero remember that the code is the minimum requirement. And then the minimum requirement is the 450 year return period. Probably, tapos there is the 10% probability of exceedance in 50 years, that's 475 year return period. So ayan ang code natin. Pero if, for example, the owner said, I don't like any cracks on my sa window ko, no cracks at all. So any earthquake. So even the minor earthquakes, then I go to what you call the 225 year return period or the 72 year return period. I-check mo yan dyan ngayon. So the displacement, Pero the ASEP will not give that one because that is already beyond, Pwedeng ibigay ng ASEP if ASEP will decide, for example, our president now and then my co-chair, si Adam, would say, sige, bigay natin. Then we will do it. But it is an extra work yan sa committee, And then the committee kasi is working for free. Kaya it will eat up a lot of our time. Pero siguro kung ang Feebles can do it, it will be a big help also, no? As referral for the base acceleration. Gawa kasi, no? Ito nga, no? Just to explain again, just to go beyond. Is there a conflict between ASEP and then the Feebles on the acceleration? None. Gawa kasi yung PSHA that they did, when I compared that, the peak ground acceleration, when inalign namin yung definition, we are the same lang. We get a 0.60 and then Feebles get a 0.57. It is the same. Yung difference na PGA, masyado magkalapit lang yan. So nakita natin na, kaya yung kunyari, gumawa ang Feebles ng, it's easier for them, yung 72 years, and then 225 years, we can just plug it in do sa code natin, So if kung gusto niyo ganto, and then you just decide on what design acceleration it is to be checked. Pwedeng ganoon, Pero for us to input it into the code, no, hindi yan. Gawa kasi sa atin lang, it is the minimum, Na because we are more concerned about the safety or life safety, not the safety of the windows. Hindi yun, Okay, yung mga mag-crack yung kanila mga tiles, We're not, that's not part of our, job.
Thank you, Sir Kaloy.
Okay. Yeah.
This is
Yes. Hello.
yes. Maybe you can add on that, Dr. Grutas.
Yes. The one if you are using the PEM 2017, the one you can download at Feebox website, and you want to use it. In that PEM, we published only 475, I think 500-year return period, and you will have difficulty in computing for the 2475, SS and S1. So that's why itong the SUM project, dito ilalabas namin yung 2475-year return period and yung SS 0.2, the short period, and then the 1 second SS. And hindi nyo yan mahanap doon sa PEM 2017. Okay, so yan lang. And about the changing of the, I think, tama si Sir Kaloy, depende yan sa owner. Of course, as sa ASEP or the NSCP, we are on the minimum. So, if you can change it, because sa analysis naman, if you do probabilistic and then you also do the deterministic, then you also check from the code, ASCE, tapos kung ano yung makuha mo, kung mag-govern yung gusto mo minimum, then you design it with minimum. And depende rin sa'yo if you want the maximum. No? Kaya nga, depende yan sa owner. No? If, kung ano yung gusto niyang design. If maganda or medyo mahal na. But for the code, I think dun lang sa minimum requirement.
Thank you, Dr. Grutas. I think we have a couple of questions for, again, still ERI. Sir Kaloy, you mentioned about truncation and post-processing ERI raw data. What are the reference that we can use in applying these corrections? And who will validate these corrections? Will the building official validate these corrections or post-processing? Sir Kaloy?
It should be the engineer on record. Kasi the engineer on record will use this post-process na data, So, kaya may responsibility, kahit na sabihin may responsibility yung the one that will sign for the instrument. It is just it is not only a matter of signing and then getting the permit. No, it is protecting the interest of the owner and also the consultant. Kasi delikado yan, It is not a straightforward thing na bahala na. No, you are there to make sure na tama yung instruments and then tama yung data na binibigay,
As for the reference daw, Sir Kaloy.
The reference. Oh, there are many. As mentioned by Dr. Grutas, there are many softwares available. For example, the Seismosignal. by Abrahamson. Oh, you can buy that, or you can, if you are an academe, you can get it for free. Pero kung you're a professional, you buy it, mura lang, 300 pounds. That's ano, it can process everything na, no, na that is needed for this kind of processing. Nandiyan na yung correction factor, nandiyan na yung intensity, lahat nandiyan na, no? That's only 300 pounds, so that's 150,000 pesos, ano? Mura lang.
Okay.
Ayun, ano?
Thank you for that, Sir Kaloy. I think this next question is addressed to Dr. Grutas. Since there is already a recorded increase in seismic acceleration installed on buildings, as provided by Engineer Grutas, should the new buildings be designed with an increased rate or a new factor to become a multiplier to the seismic loads, especially for new structures intended to last 25 to 50 years? Maybe if I would rephrase it, since there's already an increased number of buildings wherein we already installed ERI, no? Are we really getting information from this installed ERI, and this information helping us in improving our seismic data?
Yes. For PHIVOX, no, yung earthquake data, for example, 2-year data, for example, 2018, 2019, 2020 earthquake data, maliit na ano lang yon na factor, because for probabilistic seismic hazard assessment, you need very long historical record. That's why we started from 1645, no? So any added, it can contribute, but for doing the probabilistic seismic hazard assessment or database, you need a very long records of or historical data. No? If you are computing 500-year return period, then you need 500-year data. If you're computing 2,475, you need 2,475 data. So does that answer the question?
Okay,
I think
so
for instrumentation, I think Sir Kaloy for building. Because PHIVOX, we have a strong motion, also accelerograph, but deployed in the open field. I think it's in the ground, no? So it can be correlated if you have a record on the building. If you want to remove the record input from the ground, then you need the open field so that you can properly analyze the whole earthquake response on the building.
Okay. So I think that's all the questions raised to us by our participants today. We still have around 3 minutes, and I would like to use that 3 minutes to give the floor to our speakers for their concluding remarks about the topic that was discussed today. Maybe starting with Dr. Grutas, followed by Sir Kaloy.
Yes, of course, in PHIVOX, we continue to monitor earthquakes and, of course, accumulate data, no, historical data. This is with the data, we can contribute more. No, we can update the PSHA. I think every year, no, with more data coming in. No, so yan yung role ng PHIVOX, is to help the engineers, no, with the significant amount of data. No, we have strong motion recorded pre-field, no, from the ground. We have also continuously mapping, microzonation mapping, VS30, and short period, and also the long period response. So, and GPS campaigns for the slip rates, and fault mappers. We do trenching, no? Hinuhukay natin yan, yung mga fault. And then we check yung carbon dating, yung mga displacement, and kung ano na yung ilang years, ilang earthquake ang nangyari dyan sa mga faults na yan. So, I think,
Thank you, Doc.
yes, for application in the engineering community, this data, um, they're useful for the seismic hazard assessment.
Yes, I think ASEP as well as the structural engineering community here in the Philippines are very, very lucky to have Engineer Grutas from PBOX, who is really helping ASEP to improve our seismic maps for the benefit of course, of our practice, to improve our estimate of ground motion across our country. No? And I'm giving the floor to Sir Carlos Villaraza. And maybe, sir, you can, because the topic is about earthquake recording instrument, maybe you can elaborate if and answer the question as well and give us a concluding statement. If really suppliers who are saying that installing an ERI can really make the building safe, and thus the ERI really increase the building structural integrity. Like if you install ERI to your building, does it already increase the structural integrity of your building? I think that is the question. And we want Sir Kaloy to really make the statement as a closing statement for this webinar.
Yeah. ERI is a recording instrument, kaya nga earthquake recording instrument. And as such, it will just give you the behavior of the building corresponding to the earthquake that has hit the building. Pero it does not increase the strength of the building. Now we, as structural engineers, we have to be responsible. And just like what Maida said, that we are here to serve the people. And also what PBOX is doing, serving the people, without vested interest. Kasi we are here to make sure na our buildings are safe so that economically and the people will not suffer, less injury, and also the economy will not suffer, so the Filipinos can continue on living. Kasi with the proper instrumentation, it is so fast to say, okay, this building is safe, okay, this building is not safe, okay, this building has to be repaired. Kaya ganun, kaya bilis, So we know that it will affect talaga our economy. Kaya din sa mga especially the young engineers and those with experience, the old engineers, we have to work or help ASEP or help the younger engineers to get our knowledge kasi so that they can take off from the present condition or of the knowledge we have on earthquakes or dynamic analysis. Kaya magpo-progress tayo ng maganda, And then for us, Dr. Grutas, Adam, and ASEP, we will be so happy kung nakita namin after an earthquake, everything is okay. It will be a big joy also for us. Yes. Thank you. Ayun lang. Engineer Mendoza.
Thank you very much to our distinguished speakers, Dr. Rhommel, Grutas, and Sir Kaloy Villaraza, for imparting your knowledge and experience on the Philippine earthquake model and earthquake recording instruments. So to conclude our webinar session for today, Sir Adam, do you have a parting statement?
Yeah, before the participants will leave the room, the Secretariat will post the webinar assessment questionnaire. So make sure that you answer the questionnaire, because otherwise you will not get the certificate of completion if you pass the assessment. And at the same time, you also need to fill up the feedback evaluation form as a form of attendance. No? So I would like to request everyone in the panel to open your cam so that we can have a photo op. Secretariat, can you please, after the photo op, Secretariat, please post the questionnaire already. Maybe you can already start, not just give them 15 minutes to answer the question. Okay. Okay, Secretariat, I think you can now make the screenshot.